The central concept in the sequence form representation is the sequence. A sequence of a player is an ordered set of actions of that player from the root of the game tree to a given information set. We iteratively build all the sequences of player 1 and of player 2 in the picture. Initially, we have the root of the tree. The sequence of actions leading to such a node is obviously empty. However, in the spaces of the sequences of the players, a fictitious sequence called empty sequence is added. And this sequence is denoted with Q with empty set in the pedix. Then we consider the terminal node marked in the picture. The sequence leading to such a node is composed of action uppercase L1 by player 1. Thus, we report it in the space of sequences of player 1. No action of player 2 is necessary to reach this terminal node, or in other words, the empty sequence of player 2 leads to that outcome. Therefore, we don't need to add any sequence to player 2. Now we consider the decision node 2.1. Action uppercase R1 of player 1 leads to such a decision node. Thus, we add the corresponding sequence to player 1. No sequence is obviously added to player 2. We consider now the decision node 1.2. The decision node is reached when player 2 plays lowercase L1. In terms of sequences, it is a sequence of player 2, and this sequence is exactly lowercase L1. Thus, we add the lowercase L1 to the space of sequences of player 2. Consider now the terminal node marked in the picture. The sequence of actions of player 1 leading to that terminal node is uppercase R1, uppercase L2, while the sequence of action of player 2 leading to that terminal node is just lowercase L1. Thus, we add the sequence uppercase R1, uppercase L2 to the space of sequences of player 1. And we say that the sequence uppercase R1, uppercase L2 extends sequence uppercase R1 by means action uppercase L2. Enumerating all the possible sequences, we have those reported in the picture. Therefore, for instance, for player 1, we have uppercase R1, uppercase R2, uppercase R1, uppercase L3, uppercase R1, uppercase R3. The sequences of a player that lead to terminal nodes when paired with some sequence of the other players are called terminal. Instead, if a sequence cannot lead to any terminal node, it is called non-terminal. The terminal sequences in the picture are those in red. If you consider, for instance, uppercase R1 of player 1, it cannot lead to any terminal node. Instead, sequence uppercase R1 uppercase L2 when paired with lowercase L1 leads to an outcome. Importantly, a sequence is terminal only when paired with a specific sequence of the opponent. Indeed, if uppercase R1 uppercase L2 is paired with lowercase R1, no terminal node is reached. Now we focus on the strategies defined on the sequences. These strategies are called realization plans. The probability associated with a sequence Q is denoted with lowercase riq, and being a probability, it is in the range 0, 1. The realization plan RQ are subject to some linear constraints. Specifically, these constraints differ from the customary simplest constraints, since the vector of the realization plans of a player is not a probability distribution. In particular, the constraints are: first, the realization plan of the empty sequence is 1. At each information set of a player, the probability of the sequence leading to such information set, say sequence Q, equals the cumulative probability of the sequences that extend Q at that information set. Consider the example in the picture. The empty sequence of player 1 is always played with probability 1. Consider information set 1.1. The sequence leading to such information set is the empty sequence. The sequences extending the empty sequence are uppercase L1 and uppercase R1. Thus, the constraint forces the cumulative probability associated with uppercase L1 and uppercase R1 to be equal to the probability associated with the empty sequence. Consider information set 1.2. The sequence leading to such information set is uppercase R1. The sequences extending uppercase R1 at this information set are uppercase R1, uppercase L2, and uppercase R1, uppercase R2. The constraint forces the cumulative probability of uppercase R1, uppercase L2, and uppercase R1, uppercase R2 to be equal to the probability of uppercase R1. Similarly, at information set 1.3, we have that the cumulative probability of uppercase R1, uppercase L3, and uppercase R1, uppercase R3 is equal to the probability of uppercase R1. The set of linear constraints on the realization plan of player 1 can be formulated in vector form as uppercase F1, lowercase r1, lowercase f1, where uppercase f1 is an opportune matrix. Lowercase r1 is a realization plan vector, and lowercase f1 is an opportune vector. Here, the expansion of the realization plan vector lowercase r1 of the matrix f1 and of the vector f1 is reported. The first row of the matrix f1 and vector f1 corresponds to the first constraint. The second row corresponds to the second constraint, and so on. We analyze the properties of the constraints. Consider the constraints in the vector form reported in the slide. First, matrix Fi is totally unimodular. As a result, the vertices of the polytope induced by the constraints are integer, and therefore they have values in 0 and 1. This is the for law since any realization plan can assume values in 0 and 1. The vertices of the polytope being integer correspond to pure strategies of the player. Finally, each vertex of the polytope corresponds to a plan of the reduced and normal form. This just means that any vertex of the polytope is a pure strategy that, by definition, is a plan of the actions of the reduced and normal form. We focus on the utilities. In the sequence form, the utility is represented in sparse fashion. The utility is defined only for the combination of sequences that lead to an outcome. Consider, for instance, the example in the picture. The profile uppercase L1 empty set leads to 4, 4. No other combination of the empty sequence for player 2, with the other sequence of player 1, leads to an outcome. The profile uppercase R1, uppercase L2, lowercase L1 leads to 6, 1. No other combination of sequence uppercase R1, uppercase L2 of player 1 leads to an outcome. Another example is uppercase R1, uppercase R2, lowercase L1. That leads to 9, 3. Instead, the profile uppercase R1, uppercase L2, lowercase r1 leads to 2, 1. Finally, the profile uppercase R1, uppercase L2, lowercase r1 leads to 4, 2. Notice that the number of entries in the utility matrices of the players is 5. The expected utility is, as usual, a polynomial with a degree equal to the number of players. The formal model of the sequence form is a tuple n, q, u prime, c, where n is a set of players, q is a set of sequence spaces for the players, Ui is the set of sequences of player I. U prime is the set of utility functions, where the utility function is a function mapping each combination of sequences to a real number. For all the combinations of sequences not leading to an outcome, we assign the value of 0. Finally, C is the set of constraints over the realization plans. The size of the utility function of a player is exponential in the number of players and linear in the number of sequences of a player. Each player has a number of sequences equal to the number of her actions plus 1 corresponding to the empty sequence. Finally, the constraint matrix Fi has a size equal to the number of sequences multiplied by the number of information sets plus 1. This shows that the sequence form representation has a size that is linear in the game tree size.